Hello, folks. So we are back again, and this time with another mock interview round. And again, our interviewee is going to be Dev because for some reason he enjoys that, and we enjoy grilling him. So yeah, this time we have a question which is deceivingly simple, which sounds simple when you hear it, but then there are lots of corner cases and lots of things to be considered. So we thought, we'll present a case where, we try to solve that. So yeah, without further ado, let's start. So Rajat has a question for Dev. Maybe Rajat, you can go ahead.
Yeah.
So
Okay.
yeah, go ahead.
So uh, the question is quite. So this is a quite common use case in day-to-day life, and our standard library even has functions for this. But we would like to implement it ourselves. And here's the problem statement for you. So let's say if I give you a hex string which is null terminated, you have to tell me what is the decimal equivalent of it. So whenever user types a hexadecimal number on the console, it passes as a hexadecimal string and not a hexadecimal number. But you want to process it as a hexadecimal number or a decimal number, because that's how the processing should happen. So you need to implement a function hex to dec, which will accept a null terminated hexadecimal string, and you have to return the integer equivalent of it. For example, if hex to dec receives a string called 10, the integer equivalent of this is 16.
Okay. Interesting. So, can you give me a few more examples to understand, like, what
Sure.
exactly the string is, and then how do you expect me to return?
Sure. Let's say if you receive a hex to decimal of a, the equivalent is 10.
Okay.
And you can assume that there cannot be more than 8
More
hexadecimal.
than 8. Okay, so that's what
Yeah,
is
because
typically
that's the limit of
representing
the
that it
highest of
can
32-bit integer. We
32
assume
bit.
that the hexadecimal string we want to convert is bounded by 32-bit integers.
Okay. And one question that I wanted to ask is that whether the characters that, let's say, the hex can contain A, B up to F, right?
Yes.
And will that be capital characters or the small, letters?
It can be both. It's up to
Can be both.
user's keyboard what he inputs.
Okay.
It can
Okay.
be a capital, it can be a smaller lowercase, it can be a mix of both. Sometimes A can be capital and F can be small. You have to take care of all the use
Okay. Okay.
scenarios.
Okay. And I'm assuming that you want to be given this one, right? Let's say 0x 1 2 3 A, right? Like A.
Yeah, you can assume
This
that
won't be
we are stripping off 0x and just passing you 1,
0x.
2, 3, 8.
Okay, so you will all only be passing me 0x and then with some null character at the end,
Yeah,
right?
/0.
Okay, slash, oh, slash 0. Okay.
Yeah.
Hmm. Okay, it can contain both the. Okay, let me just write down the use, like the different cases that I want to cover. So, there is, it's stripped uh, version maybe. Okay, so it's 0x is not there, so I don't have to take care of that. The second thing is it can contain both the characters, like capital or small. Okay, and then third thing is uh, it's less than, like it can, the data can be accommodated in 32 bit, right? So uh, it will be less than 9 characters,
Yes.
right? Like I'm not including the null character here.
Yeah.
Okay. Okay, and I'm given the character string
I think we
hex to
should
deck.
also cover whether there can be a negative number or not.
Negative number.
Rajat, do you have any preference on that?
You can assume that there can be a negative number.
Okay, so the negative number as in like
Preceded by
minus
nine, preceded by minus.
minus 1 to 3, right? Let's say this is in the hex, then I'll have to convert something like minus and then have, let's say 1 2 3 converted to
Decimal.
okay, that's okay.
Not actually, right? So in hex, the negative is if you are taking a hex integer and you want to display negative, it's the topmost bit. If the
Right.
topmost bit is set to the MSB, that is the last 31st bit is set to 1, that means it's a negative number.
Right, so
No,
yeah, there are two
actually,
ways.
not just that, it would be 2's complement of the
Two's
positive.
complement
Yeah.
of.
But I think that would be done by just, multiplying by -1, let's say.
Yeah, so let's just assume all numbers are positive, and you have to just return an unsigned int. Let me just we can cover
Okay.
that corner case later
As a follow-up, yeah. Maybe.
as a follow
Okay.
up, but let's assume that it's an unsigned int
Okay.
that you have to
Okay.
return.
So everything will either be 0 or positive. Okay.
Yeah.
Okay.
So your range is 0 to 2 to the power 31.
Okay. Okay. So what I can do is like how we typically convert a hex number to decimal is that, let's say you are given 0x. I'm using 0x1 to 3, so that we know that okay, it's a hex number. And what I can, like what we typically do is in the conversion we will have something like this, that the, let's say 16 to the power 0 into whatever number at 0th position, which is 3, right? Plus 16 to the power, let's say 1, and then we'll have number 2 multiplied by, and then 16 to the power let's say 2, right? And then we'll have a number which is at the position 2, so which is 1, right? And whatever this number comes out to be in the decimal, I will have that as a response, right? That is what I'm thinking. So that's the usual how we convert a hex number to a decimal number. Now other way is that, let's say if I'm given the mix of characters, let's say if I'm given f12, let's say f1, then what I can typically do is whatever, like 16 to the power, let's say 0 into 1, the least significant digit, and then let's say 0xf. So here f typically represents 15, right? So what I can typically do is, let's say there is a capital character F minus a capital character A and plus 15. So that is O plus 15, YF15 plus 10, I think. If 10 is there, then it's 0, right? So if, let's say the character is F, or let's say character is A, then it will be 0 plus 10, so that would be 10, right? So F minus A, which is 5 maybe, and then plus 10 is 15, right? That is what I'm thinking. And if there is a small character as well, let's say there is a small character A, so that would be like 16 to the power, so here I forgot to add 16 to the power 1, and that's into, and then here 16 to the power let's say 2, and then multiply it by, let's say this is F minus A plus 10, right? So that would be the conversion to the decimal. Now important thing for here for me to note is that if I'm given a capital character, if I'm given a small character, if I'm given a digit, that I'll have to figure out with using some conditional operations, right?
Okay.
So that is what I'm thinking. I hope I took care of all the use cases. Now I am not considering like the negative, so that's anyway not in the inputs. uh, Both smaller capital 12 characters, all numbers are positive, this is not there. Okay, so I think I have covered all the possible cases in the advance. Now I can maybe write down the code if you want.
Yeah, maybe. Go ahead.
Okay, okay. So okay, let me check. So what all I have to do is to traverse through all the characters. So what I'm given is this. In this case, I'm given 1, 2, 3, and in this case, I'm given AF1, right?
Right.
So what all I have to do is to let's say use the for loop, and even in this case, let's say I'll have to figure out the size as well. So will I always be given the size as 8? Because in this case I'm just given the pointer to the string, so I really don't know the size here, so it could
Right.
be like 0000 AF1,
Now
right?
it won't be, the length won't be fixed at 8, I believe.
Yeah.
Right,
It
so
could be
then we'll
anything.
have,
So
okay,
you
in
you
that
have
case
the
I'll
null
use
terminator.
I'll use null terminator,
Hmm.
yes, to figure out that. Okay, so what I can do is, why not so I'm not going to use since there are inbuilt functions to calculate even this hexadecimal or the size of this string, so I'm not
Right.
going to use any of these
And why
functions
not?
here. uh, just want to implement every
I think
functions.
that's a good point, because generally in
Right,
embedded systems we don't usually have the luxury of
right,
C libraries,
right.
so we have to develop everything else. Yeah, go ahead,
Yeah,
please.
yeah, so I'm assuming that nothing is given to me
Yeah,
in
yeah,
the
that's
advance.
good.
Yeah.
That's good.
Okay, so what I can do is I can use a while loop operation in hex. So first of all, I need to figure out if the hex pointer is pointing to null or not. If hex is pointing already to the null, I should return let's say some error that I am not the input is not valid, right? So I would something say invalid arguments, right? So that kind of, and then here I can
But
define,
then,
okay,
okay,
So
yes, of course, like that have to be figured out, because I'm not given the int, rather I'm given unsigned it, so I'll always have to return a positive number, and that can signify that it's represented in a decimal number, right? It may
but
be the representation of
that's
a,
true for int as well, right? Even if you return minus one is a valid integer. I can send you a hex that can be -1.
right. But then like if someone is receiving -1, then he can probably figure out that, okay, this number, like there is some error, right?
No, right?
Because
What
they
if I
given you
give
all
you
the
a
positive.
number and you return me -1? It's a valid output, right?
Right,
Minus
yeah,
one is a valid output. So
yeah,
so let's assume that I am always going to pass you. The error checking has already
right,
been done before passing here.
okay,
right.
okay.
So the char pointer has already been checked to null, and only then
Mhm.
when it's satisfied, they pass the char pointer over here.
Right, right. So
But
I'll like,
I still like that you tried
Yeah.
to cover all the conditions. That's good point.
Yeah.
Uh,
yeah,
or in a case, I think we could have maybe pre-negotiated. Hey, this number will
Yes.
always be designated for an error scenario,
right,
like
right.
int max or something, or
Yeah.
negative.
Yeah, yeah. Okay. So I'm typically iterating over all the characters in the hex, and then figuring out if I haven't reached the null. If I haven't reached the null, I could still, keep incrementing. So that's what I'm going to do. Okay. So one thing I am thinking here, that I don't even need to, calculate the size. I know that where is it terminating, right? So all I need to do is start with I is equal to 0, and then see if hex I is, let's say, okay, so here one thing is that, let's say if it is greater than equal to a, and and if hex, so I really don't recall the the ASCII value of these. So I
Mhm.
will have to use some extra conditions here,
Okay.
maybe so to handle that. So if that is the case,
Hmm.
then what I know is that this number, or I can just have a digit, let's say int digit, which is initially 0. So it can be digit which is, let's say, it's equal to 10, or let's say whatever is hex, and then I can subtract it with a, and then add as 15 or 10, sorry. Right, so that's the one case. If, and I'm going to do the similar thing for else, like for capital letters.
Okay.
So let me do that. If x is greater than a and then smaller than oh man, like I don't given the entire alphabet, I'm just given a. Okay, why I did use z, it should be f. Oh man, that's embarrassing. Like
It's
that is
fine.
what
But
yeah,
anyway, we
that's
assume that there won't
yeah.
be any
Yeah, so like
error.
I usually figure out, okay, if it is alphabet character or not, and that's
Right.
where I used
Yeah.
z. So
Mhm.
instead of that, I should use only f, right? So
Right.
yeah.
Okay.
Okay, hex minus, here I need to use capital A.
Mhm.
So then I have figured out the digit. If that's
Mhm.
not the case, okay, what I can do here is that hex I minus the character 0. That's all. So this is the character 0. So if
Okay.
minus here, minus, yeah.
Mhm.
So if, let's say, if it is 0, then it will turn out to be 0. If it is 1, then
Mhm.
that subtraction would be 1,
Mhm.
because I'm correct.
Right.
This is
Right.
an ASCII value, and this is again being
Mhm.
converted to ASCII, right? So
Mhm.
ASCII difference would come out to be a digit from 0 to
Mhm.
9. And if that's not the case, then I am running into one of
Mhm.
these conditions.
Mhm.
If not, I am assuming that these are the given inputs. Otherwise,
Mhm.
I would have written something, some error or something.
Mhm.
But let's assume that that's the case. Okay, so what I can do here is that, let's say I'll have a number as okay, I am int. Let's say this is a decimal number. After conversion to the
Mhm.
decimal. So what I can do is, depending on the power to 16th,
Mhm.
16 to the power, if I want to understand 0, then 16 to the power 1. Okay, now what I need to do is to figure out the power of
Mhm.
the, and I'm assuming that I'm not given the power function as well.
You can assume,
Power.
let's for the instance assume you have the power function.
Mhm.
Okay, so let's say then I'm given the power, and then
Mhm.
whatever I is here.
Mhm.
Okay, I'll start with that. Okay, so actually I'm starting from 1, and here I need to know, okay, what is the size of the
Mhm.
uh, of this string, because if
Okay.
I was started here, then I would have used I, right?
Mhm.
Anyway, to get the power of the 16th. But now I need size as well. So what I can do is I can typically calculate the size. So int length is equal to 0, and then while. Okay, I think one of you are touching the mouse, I guess. So it,
Maybe can you scroll up, Dave? I think we are going a bit down, so our views is coming so see.
yeah,
We scroll up by some.
yeah, I'm here already.
I mean, yeah, exactly. This is better.
Yeah. Okay, let me do the same thing. Why I had that? Okay. So I hex I is not equal to, let's say, 0. Then I'll
Okay,
keep
are you
counting.
typing something? You're not seeing.
Yes,
it.
I'm typing something in the beginning
Okay,
at
now
line
it
number
can.
27.
Now it. I think now it reflected. Yeah.
Okay,
Okay,
so
let's
length
follow
plus
it
plus.
today.
So I'm typically calculating the length here.
Okay. Sure.
Okay. Okay, so here then like what I need to do is to figure out this length minus I. So if let's say length is 1, then what I need to do is just 16 to the power 0 into whatever value it is, and then that the digit will be added here, and then all I need to do is sum of all these things and then return decimal.
Rajat, I think it's not reflecting. So
No, I think Dave is not typing anything.
Yeah, I'm typing on line number 41.
why is it?
Okay, I'm not sure.
Can you type again? Can you type something?
Type again?
Yes,
Okay,
Yeah,
now
it's
it's.
reflecting. Okay. Yeah.
returning decimal.
Number. Okay.
Yeah.
So maybe Dev, can you repeat what you did during the last part? I
So
think we missed that.
yes, so what I did was that I calculated the power to the 16th. So if let's say the digit is like the size is only 1, then I just have to multiply it by 16 to the power 0, right? So my length would be 1, and then I is 0, and then I'll have to remove 1 from there, right? So that would be 16 to the power 0, and then whatever digit I have got here, right? So that's the digit I'm going to add to the decimal number.
So, Dave, do you think you will get the correct length?
Okay. I think initially length is 0. Okay. My iterator is not incrementing here as well. So it's an infinite loop. I need to take care of that. Similarly here, here I also need to do this. Okay. Now I think it should give me the actual length. And then, yeah, that's okay. So yeah, let me take an example to figure out okay whether this algorithm would work or not. Okay, so let me take an example. Let's say I have a number which is, let's say, 0 1 2 a small b, and then let's say, and then appended by a null character, let's say, right? That's what I have in input. So so this condition is anyway I don't require. So what I do is initialize I with 0, length is equal to 0, and then see if the hex I, whatever initially I is 0, so it will be 0. So the number that it represents is 1, which is not null, so length will be plus plus. So here length is 1 2 3 4, and then when it goes to null character, it exits without entering to the a while loop, right? So my length would be 4 here, and then in the decimal part I'm assigning it with 0, and then what. Okay, one thing is here is that I need to do unsigned, because then like so the unsigned int has some more positive, like numbers which cannot be put into int, right?
So the range
Like,
becomes
yeah,
more.
twice of what
Yeah.
integer can do,
Integer.
right? Yeah, so then if you give me the numbers in that range, then I will be responding with some wrong output,
Right.
right? So that I need to take care of. So now I am starting with, let's say, I again 0. I need to do that. So hex 0 is not equal to null, and the digit is, let's say, 1. It was 1, so 1 minus character 0, so it would return 1, and then that 1 will be proceeded further because these will be false. These conditions will be false, so the decimal would be power of length is, let's say, 4 minus 1, and I is 0 here, so that would be 3. So 16 to the power 3. And anyway, at this point, we need to have power 0, 1, 2, and 3. So that's right. And then whatever digit I have, calculated, so that would return 1. So the decimal number is 1 at this point. 1 into 16 to the power 3. Right? And then okay, then when I exit this, like whenever I go for another, then I would be 1. So then again I am here 2. So let me have this only. So let's say A is there, A is the next character. So what I do is, this condition is false. This anyway started with some value. So this digit might have some different value. Let's say this would have, let's say, A minus 0. So that would be some whatever the sky difference comes out to be
65 minus 48. So
yes. So that would be some different.
9.
Yeah, 9, maybe different value. I
19.
don't, 19. Yes. Okay. So then it would be modified by
70.
this, because this condition is true. A greater than A and less than F. So this would be true, and then this would return like whatever A minus A plus 10. So this would return 10. And then what I do is 10 into 16 to the power 1 here, because length is 3 minus 1 minus 1. So that would be 16 to the power 1.
Okay.
Why am I doing 16 to the power that? Okay, yeah, I need to do that. Okay, and then digit. So I have calculated the digit. Now in the next run, I'll be, I'll have something like this, where this is B, and then this will be updated by this digit, and then I will be returning the decimal number after I reach this null character, right? So that's so I think it is going to work for these cases.
Yeah. So I have a small question. Do you think you need to check it twice for capital A and small a?
Are they consecutive?
So let's say if you
Like
already
need to-
checked for small a and it turns out to be a range between small a and small f, do you need to check it for capital A and capital F after that?
Okay, so can someone tell me what is the value, ASCII value of this character?
is,
A small
I think, 96.
96. Okay, and then that is 65. Yeah,
Yeah.
capital A is 65. Okay.
Sorry, 97. My bad. 97, 65, and the 0 starts from 48.
Would be 48. Yeah. Okay. So I think, yes, you are right, that if my hex is greater than, let's say, 9, maybe, right? So for 9, it would be some value, let's say, okay, it should be 57, right? 48 plus 9, that's 57. So if it is greater than 57, then there could be two cases: either it is capital A, either it is small character A. So then I'll again have to check for another if condition. So if it is, let's say, capital A, then I'll just subtract 65. If it is small, I'll go with 97.
So what I meant is either it can be small or it can be bigger, right? It cannot.
So can you replace if with something else? That's, I think, what his question
Yeah.
is. The if on 46.
You don't need to check both. It can either be a small. It can either be a small a to f, or it can be either be capital A to f. It cannot coexist at the same time.
Okay.
So the second if is not actually needed. You can replace it with something else.
Okay. So you mean this one?
Only
just the if keyword. Yeah.
Yeah, just the if keyword.
Just the if keyword. I need to replace it with something else. Okay, let me check. So I have taken care of this. That anyway, like else I can use though. But in that case, let's say I need to use. So I think what you mean by is this one, I guess. Is this what you meant?
I mean, given Rajat's assumption that there
Right.
is no error, it might work. But if you would have to
But
make it
then,
error
but then, like my
proof,
digit would always be modified by this,
Yeah.
right?
right? So
Can
that
you
So
condition will.
right?
what you can
What
do?
else?
What can you do?
Okay.
You still
What?
need
So
that
then I.
condition.
Yes.
Yeah.
Yeah.
That's it.
So I still need, let's say here, let's say if it is bigger than a, then there are two possible ways, right? So what I'm trying to typically do here is, like, let's modify the code. If it is bigger than a, so if hex I is greater than a, then what I can do is digit is equal to whatever this is, right? So small f. Okay, sorry, yeah. Then what I do is this. Else that part anyway, like whatever is remaining.
You were
I
already
think,
checking for a range. I think your conditions were already perfect. You were already checking for correct ranges.
yeah, yeah,
I think what
okay,
Rajat meant was Dev, that
Just
instead of
replace it
checking
with
it twice, you could have used if
mhm,
and else if.
yeah. If you go
yeah,
back to if you undo everything and go back to how it was earlier.
okay, let me do this.
Yeah. Yeah.
That this
So
was.
if you just
Huh.
change the second line number 48 if with else if, that just makes your program efficient.
Hmm.
Okay, oh, okay, you meant by that I don't want to recheck this condition
Hmm.
again.
Yes.
Okay, okay, okay.
It
I
just
thought
makes
maybe
your
like a
program
small.
much more efficient.
Yeah, yeah, yeah.
It
I
was
know
a
that. Okay,
it was
now
a minor net, I
because,
think. Yeah.
yeah,
Yeah.
so if it
I even hinted you
executes.
there is nothing wrong with your program
Yeah,
technically.
yeah, I thought maybe like there is something like I can just do this without just one if condition and then not having, multiple ifs or else.
Hmm.
But yeah, right, I think in this case what it do is it would calculate this expression. If it is false,
Hmm.
then only goes this,
Actually, our
otherwise it just
mind,
executes
yeah,
this.
our
Yeah,
mind works in a funny way. If there are
yeah,
only two conditions, we naturally tend to use if, else, or two
yeah.
ifs. We forget
Yeah.
about else if ladders and stuff.
Yeah.
Yeah. No, so I
So
did not actually forget, but I was like, okay, if
Hmm.
one of them is true, then I don't have to worry about in the else case. So, like sometimes what happens is that, uh, let's say first if is true and then second if is true, but here
Hmm.
that is exclusive, right? So either one is true, either two is true. Both cannot be true, right? So
so
So even in else
yeah,
if it is the case, right?
yeah,
It is used for exclusivity. Right?
yeah, nice. Yeah, I think this is something I never like taken into consideration. I think this removes,
Two
execution of line
checks.
number
Yeah.
47.
Yeah.
Yeah,
Two
two
checks
checks.
basically.
Yes. Yeah.
yeah. So okay, I have to put an embedded question out there. Power of 16 is not efficient. Can you optimize it?
Hmm.
Okay. Okay. Yeah.
You don't have to worry. Ideally, just for our audience, compilers
Hmm.
are smart enough that
Yeah.
when they say power of 16, they are going to optimize it themselves. But still,
Okay.
let me put a question: how will you optimize this line number 50?
Line number 50. Okay.
Yeah.
Maybe implement the power function,
Hmm.
given that it is going to be power of 16.
Yeah, I think I can implement it through like
Hmm.
some algorithms I know.
Hmm.
Okay, let me implement it maybe then. So what I'm going to do is I'm going to implement it on line number 17. If you follow me,
Hmm.
int pov, and then there is two integer. I think int a. Okay, this is base. I think what I call it base, and then integer. Uh, what do you call the other one? The power
Exponent. Exponent.
exponent. Yeah, yeah. So what I can typically do is So what? Okay, let me do some mathematics on a pen and paper. So let's say I have 16. If I move 16 by 1, that would be, if I right shift 16 by 1, that means it's multiplied by 2 actually. Right. Okay. So what I typically want to do is, here is that, let's say I have power. So power would be, let's say, base into whatever exponent is this, exponent into multiplied by 4. Is that correct? So here I'm typically thinking about the power of 16 rather than the generic power function. So I should say power of 16 here, right? Modify it by something like that. Then I don't need to even pass 16 here. I just have to pass just one exponent component, right? So then my base is anyway 16. So what I typically do is, if if my exponent is, let's say, 0, then this returns 16. Okay, this returns 16. If my exponent is 1, what I can do is, why would I do 16 here? It's 1. So if exponent is 0, like exponent is 0, then this is 0. So shift it 1 by 1, like shift 1 by 0. So that would be 1. If my exponent is 1, that means I need to shift it by 4. So if I shift it by 4, then it is so 2 to 4 times 2, right? If my exponent is let's say 2, that means 16 to the power 2. So 1 to the power, like 2 to the power 8. So I think this should return the correct power 2 to the 16th power, like 16 to the power whatever exponent it is. So this typically does by right shifting anything,
Right.
1. Yeah. I think there is another generic function that I used to do. So let's say int pow. So there I used to apply some binary search or something.
Divide
Int
and conquer,
means-
basically.
Yes, divide and conquer. So you don't have to calculate that operation again. It's like if your exponent is, let's say, and 0x1, like if it is odd, so what you typically do is return whatever your base is. So it's like base to the power exponent. So let's say base is 5 and to the power 3. So 5 into 5 into 5. What I need to do, that's what I need to do.
Right.
So base into power, and then base to the power exponent by 2. Right?
Okay.
And I can calculate this. What I was going to do is that, let's say, calculate this int power, some power value, and then to power into power. So that's the one.
Okay.
Otherwise, what I can do is, okay, exponent. That's anyway, I think, taken care of. 3 by 2 is 1 anyway. So I don't have to take care of 1 explicitly. Otherwise, what I can do here is that int tmp, which is, let's say, 1 initially. Tmp is equal to base. So whatever power I have returned, I can do this, just temp. I think this is what it should. And then in the case of exponent, so I'll have to take care of the base case. So if exponent is 0, then what I do is return whatever 1. If it's 1, then I need to return if exponent is 1. So I need to return base only. So these are two base conditions. And then if exponent is odd, then it is anyway taking the base as part of the temp. And then temp is here returned as part of the, and if it is even, then my temp is anyway 1.
Yeah.
And then power into power. So this typically takes off, a log of exponent, whatever exponent initially is.
Right.
Yeah.
But anyways, you can just simply right shift the digit by 4 and that will multiply it by 16.
Yeah. Yeah.
Then his generic function would work if he wants to convert it into other
Yes.
Any.
bases
Yeah.
as well.
Yeah.
Nice, man.
Okay.
Nice.
Nice.
Okay.
Okay, Rajat, any more follow-ups? Yeah.
Oh, I guess this is fine. This works.
Yeah. Great.
Okay. How am I doing on the time? Is it, are we?
Yeah.
Minutes, 41 minutes.
Okay. Okay.
Cool. Cool.
Okay.
Okay.
Okay, with that, I think we'll say goodbye to you folks. Those who were here till now, thank you for staying, and
So-
hope you got some insights from this. Yeah.
Yeah. So
Yep.
just I would add it. So always think it, and I think we covered this in bit masking as well. So whenever somebody asks you to multiply by anything power of 2, that's a hint that you should use right or left shifts.
Correct.
Right shift to multiply and left shift to multiply, right shifts to divide, because those
Right.
are more efficient and hardware can optimize them into a single instruction rather than multiple instructions.
Right.
You don't have to
Right.
take it. Nowadays compilers are so smart that if they see anything 2 to the power, they just do a left shift rather than doing multiply and divide instructions.
Right. Thank you.
Yeah.
All right. Awesome. See you folks in the next one. Take care. Good day. Bye bye.
Bye bye.